In this problem, we're matching the graph with its function. And so one of the things we want to do here, since we're working with secant, cosecant, tangent, and cotangent, is to remind ourselves that tangent and cotangent have shapes that look like x cubed, and secant and cosecant look like up and down parabolas. So that's one thing that we can do. And then the other thing we can do is look at, does the graph go through the origin? Does it not go through the origin? Does it go through the y-axis or not? What are its vertical asymptotes? Am I moving the graph left or right? That kind of thing. So if we just take a look at number 1 and maybe number 5 as examples. So for number 1, we want the cosecant graph. So I know it's going to be B or C because those are the graphs that have parabolas. And secant and cosecant are parabolic graphs, and also they have a period of 2 pi when they're the parent function. And so now I'm working with cosecant in number 1, which is really 1 over sine, and it's negative cosecant. And so when I'm at 0 on the unit circle, that's the coordinate 1, 0, and the sign there is 0. So when I'm at 0 for x, cosecant should be undefined. So I'm liking graph B because there is nothing on the y-axis, so that would allow a vertical asymptote to occur there. And then it's negative cosecant, so it's been flipped, and so we are choosing B for number 1. If I were looking at number 5, so let me do some erasing here. In number 5, we're working with tangents, so we want a graph that looks like x cubed, and that one could be a D, E, or F. And tangent normally looks like x cubed, so I'm liking for that one A or D, because E and F look like the opposite of x cubed. And for number 5, I want tangent. And then it's moving the tangent right pi over 4. So I am liking D because tangent would normally go through the origin and look a lot like the x cubed graph. And then since it's got a period of pi, it goes from negative pi over 2 to pi over 2. But we want to move it right pi over 4. So instead of being at negative pi over 2, it would be at negative pi over 4. So it's D for number 5.